Okay, let's get working. This is 416, video number 52. We're talking about conversion in the Anglo system. Some textbooks and maybe your YouTube videos, which you love so much, might use the word standard system. And all it refers to is the system used in the United States, which is derived from medieval England, believe it or not, and is only used in this country that I'm aware of, and maybe other isolated places in the world. Everybody else, Europe, England itself, where it originated, are using the metric system, which of course is far superior to this system. However, it's futile to complain about this and try to ignore our system, because after all, if I tell you a 1.8 meters tall, you're going to sort of scratch your head and look at me and not really have a good idea. Whereas if I said I'm 5'9", then you say, oh yeah, I formed an idea in my head of how tall you really are. And that goes on for football fields, so many things that we can't. If you want to buy a house, you buy it, you judge the size of the house per square foot. Whereas in Europe and England and other countries in the world, it's square meter. So we're sort of embedded in this system. Some attempts have been made to change it, but unsuccessful. So on the Regents and on the test that's coming up, they expect you to be able to convert. And we're going to use a conversion that isn't dealt with on the test, so that would be enrichment, but the same ideas are going to apply, and we'll use them in problems that we're going to do. So I'll just briefly review something you could get in any YouTube video. A mile is 5,280 feet. And I'm going to cheat a little sometimes in the future. 1 yard is roughly equivalent to a meter. A meter is really 39 inches. But we'll let that go, since we don't, in most of our problems, really don't need that much precision. And a yard is 3 feet, as you probably know, which in turn is 36 inches. So it follows instantly that 1 foot is 12 inches. And we don't get any smaller than inches. And we all have an idea of what an inch is, which shows you how primitive the system really is. But as I said before, it is the way it is, and we want to have to deal with the system as we have it. So, with that in mind, I'm going to propose a simple problem, and I'm going to solve it a certain way. There are other ways to do this, but I'm going to solve it a way that I think your average 8th grader, by the way, I can erase this, you guys can use it anytime you want, look it up, pause the video, whatever you need to do. You'll also, because of the primitiveness of our system, you'll definitely need a calculator, since this doesn't lend itself at all to scientific notation. Any serious science course, the material's given in meters, millimeters, centimeters, in kilometers, etc. But again, it's embedded in our system, even in our psyche, to use that word. So I'm going to propose a simple problem here, and this problem is just saying an object is traveling at a steady rate. You should be familiar with that word, 30 feet per second. So I certainly grew up thinking feet, yards, and everything, but I don't really have a clear idea of how fast it's going, be it steady or at an instant in time. And the problem would be, let's see if we can understand that. So we might want to convert this to, what is it going, miles per hour. And then in miles per hour, since we're always in cars and bicycles and whatnot, I can get an idea of how fast 30 feet per second really is. So let's do some work here, and let's convert it. And there are different ways of converting, and you can get YouTube videos where you're converting in certain algorithms and stuff like that. But I'm going to use common sense and calculator to do this problem. So let's see what happens here. I'm going to write it out as a ratio in slope form. There's 30 feet, 1 second. Okay? So in 2 seconds, you'd be 60 feet. In 3 seconds would be 90 feet. You probably heard me say that many times as we talk about slope. If it's going at a steady rate, that would be the case. And I need to know how fast this is traveling miles per hour. So I'm going to convert 30 feet into miles per second. Okay, so there we go. There's the small one, 1 second. And since I can't work with scientific notation, I'm forced to use calculator. I told you there's no escaping that in this math. And I'll round a little. We're very familiar with rounding. And I come up with 0.0568. So I'm way out there. Let's see, 10th, 100th, 1,000th, 10,000th to a millionth. Goodness gracious, you can't do better than that. Miles per second. Everybody see what I did? Okay. So now I'm going to use common sense now, and I'm going to multiply it by 60, which will tell you what the miles per minute are, and then by 60 again, which will tell you what the miles per hour are. So you see what I did? I found a unit rate right here using a calculator, and now I just multiply it out, and I don't need precision, I just want to form an idea of what's going on. So I take my number and I multiply it by 3,600. 60 times 60 is 3,600. You don't need a calculator for that. And bango, out comes 2045, and I'll leave it there since I'm going to round to a tenth here, an hour. So I did it, going about 20.5 miles per hour. Not that fast. So my intuition when I first set up the problem says, wow, you might be going 30 feet 1 second. That seems so fast. Actually, if you're in a car, you're just going 20 miles an hour. Even a bicycle goes along at a rate like that. So that's interesting. Let's check our answer. Let's see if this makes any kind of sense here. And I won't get the exact same answer. I'll just use 20 miles per hour, and when I go backwards, I'm going to lose a little bit of whatever, and I'm going to try to get it back. So let's see what's going on here. I'll say, rounding to a whole number here, I'll say I'm going 21 miles per hour. So I'll write that out as a 21 miles, 1 hour. So you want to work along with me? I'll put, and again, I won't get the exact same answer, but I'll definitely be in the ballpark. I have to get close to 30 just to see that you can go back and forth on this kind of math. So let's see, 21 miles. So that would be times 5,280, and that would convert the miles that I did in an hour into feet. Okay? And now, since 1 hour contains 3,600 seconds, as we talked before, 60 times 60, now I want to see what happens when I get this number here. So I'll multiply 21 times 5280, and I'll divide it on the calculator. Whoops, I better get an answer here. 21 times 5280, enter. It's a bad idea to do it piece by piece. Use the enter button all the time if you can. I get 110,000 whatever feet, which doesn't interest me. The number's too big. And I'm going to divide that by 3,600, and bango, I come up with 30.8 feet 1 second. And we can see that's a thorough enough check to see what you can do. Okay? So I'm going to give you two basic simple problems, okay, that you can do yourself. And I'm just randomly making up numbers here. And I imagine an object. So just cleaning this off. And I'm going to propose a different kind of problem using the English that we know so well. And you know, in Montauk, we have a jogging club. Ooh, they get mad when I use the word jogging. A running club, runners. And I'm going to propose a problem there. And you'll be surprised when I do it tomorrow what the answer is. So as a practice, let's do it the other way around. 60 miles an hour. Pretty much what you do on a highway if you're following the rules. And I don't want to put a 5 there because 65 is the maximum supposedly. That's what a car's doing. So I need to know how fast okay, how fast that is, feet per second, okay? So that is right there, and I'll leave you to do that. I'll do that on the board tomorrow, on the whiteboard tomorrow, and I'll check it going the other way. Once I get this feet per second, I'll just go back the other way. So I know that I'm in the ballpark. I understand what I'm doing. So you get a little bit of practice there. I'll make a note to do that tomorrow so you can see. And again, as I've been saying, you really need a calculator when you're doing this math. Now, I'm going to propose, since this is enrichment, I'm going to propose a problem. I'll put it over here, thinking of the running club, the joggers club. I don't know if you've ever watched a marathon. Certainly, a lot of you guys are aware of it. And we have a couple of kids who are runners in my class. And I'm going to say, we say he does, I'll use he, does a 5-minute mile. And that's the language that runners and most of us, a 5-minute, let me just put minute there, a 5-minute mile. And anybody who's like Mr. Sirocco in your school, who's a jogger says, wow, that's pretty good, that's pretty fast, that's pretty impressive. I don't think anybody in our joggers club can go that fast. And we have people who go faster than that, and they're doing it over the course of the marathon, the New York Marathon, which is 26.2 miles. So you can imagine what an amazing athletes they are. And I'd like to know, I'd like you to tell me how many feet you tell me. How many feet is this guy traveling? Is he traveling per second? Just put it over here. The whole board is available now. Okay. Now, you'd be surprised at the answer, how fast these guys really go, if you have any sense of distance. So I'm going to leave that out there, and we'll be back to this as we start getting ready for the test next week, where we're going to make objects and things like that they'll give you in yards or feet or inches, and they'll certainly, how many feet here, sorry about that. Looking off the top of your head, maybe everything. How many feet is he traveling per second? And that's a question that you really might want to consider. And when I come up with the answer tomorrow, or you want to email me one, that's a great idea. One girl in 804 emailed me her work yesterday, which she said she got on the internet. Obviously, a lot of these websites, if that's what they did for her, certainly doesn't get it done. So see what you can do here for me on this one, and I'll solve that tomorrow. And again, I use the word intuitive all the time because this is a problem that maybe you can't do it, I get that, but don't tell me you don't understand it. Anybody understands a problem like that. So the guy does a 5-minute mile. Tell me how many feet is he traveling per second? And like I mentioned before, some of the runners in the marathon are doing 4 minutes 20 seconds, 4 minutes 15-second miles, which is just amazing. All right, so I'll leave that there. This has been your enrichment for today. I'll do the problems tomorrow, and then we'll start talking about getting ready for the test, which is being put together as we speak now. Okay.